welcome everybody to the first ever LQB280 Jeopardy game. If you haven't joined in today and would like to join in, please follow the instructions here. Pick a team to join. Go to the buzzin.live, use that code there, and then pick a include. Oh, you can actually pick a team, so you don't have to include your name, but that would be handy just for my own sake, so I know which team to award points to would be a good thing. However, before then, I know that we only recently just learnt about the Sanger sequencing, and so it's probably the weakest area. So we're gonna go and do a few slides just on Sanger sequencing, maybe 4 or so, and then we'll jump right into Jeopardy. Which brings us to the man, the myth, the legend himself, Frederick Sanger. Not only did he get 1 Nobel Prize, but he got 2 Nobel Prizes. One for his work on Sanger sequencing and another one for his work on nucleic acids in general. And so what made it so good that it could get you a Nobel Prize? Well, we've been looking at identifying mutations, right? When they have a enzyme cut them. So if you have a mutation that can be cut by an enzyme, you're all good. But what happens if you have an enzyme that can't be cut by an enzyme and you don't end up with this gel where you have the 2 lines? How are you going to actually be able to figure out what's going on, what the sequence is? And this is the man that came up with the basic concepts behind it. In essence, you've got your sequence here that you're wanting to get your Sanger sequence for, and you have a 1 primer. You don't have the 2 like we normally do in a PCR process. You only have 1 primer, which binds to the top here, and then binds to the 5' region of what you're trying to expand. And we have special nucleic acids, which are called DDNTPs. And what makes them special is 2 things. Firstly, they fluoresce under laser excitation. Excuse me, I told the music needs to come down a little bit. They fluoresce under laser excitation, and they also stop the reaction as well. So you include these as a mix into regular DNA molecules, and these ones are called just DNTs. And so eventually you undergo a PCR-like process, and then you have a bunch of different sizes of sequence, right? So because you're not going to have your sequence go all the way through, because these terminate the PCR reaction, you're going to have a whole mix of different sequence lengths, and the very last one is going to be fluorescent. So if you have a bunch of different sequence lengths ending in a fluorescence, what you can then do is you can use what we call capillary gel electrophoresis, which is the same as what we were doing before, the gel, right? Except it's in a very thin capillary, so it's easier for them to separate out. And then you separate out all these sequences in terms of their size. And in the capillary, you then have the migration going through a laser, which is going to excite the final sequence and give you that fluorescence, right? So you start off the first one that started off very short, maybe it's only like 10 bases long, all the way down here is going to get, yes, Haley, thank you. It's going to get your fluorescence first, and it's going to tell you that at this particular point, we have a red fluorescence, which is equal to thymine. And then you'll find your next sequence, which is a little bit longer, maybe it's 11 base pairs long, is going to come out to be green in the green fluorescence from the laser, which means that at the 11th position, it's an adenine. And so you do that all the way down as it goes down, and then you eventually get these loops here, which indicate the fluorescence at that particular base pair as the different sizes of your sequences gets flowed through the capillary gel. So in real life, what does it look like? It looks something like this. So you have your reaction down here where you have your big old mix of all your different sequence lengths down here in your 96 well plate, which then gets loaded through here and through these capillaries which stretch them all out and uses the same electric pull so that you end up having your different sizes your different sequences stretched out in terms of size, with the smallest ones going first and the largest ones going last, and then going through the laser and then through the flow through to give you that overall detection there. So how do we use this to find our point mutations? You're gonna have two loops at particular points, right? So you might have a nice, clean, fluorescent marks all the way down, very clearly being one particular nucleic acid, and then you end up with a double nucleic one here. See how we've got the letter N to indicate that there are two fluorescence arcs, or there's multiple. And you see that we've got the one allele being a T and the other one being a C, because when you're doing with human DNA, you've got two alleles, right? So that's how you ended up there. So just to give you one more quick recap of Sanger sequencing, the reason why we like it is because the Sanger sequencing doesn't require your mutation point to be cut by enzymes. You can find it without enzymes needing to be there. What we do is we have a sequence of interest and we have one particular primer, and we have a mix of regular nucleic acids, and we have a mix of DD-NTP, which is a specific type of nucleic acids which fluoresce but also which also terminate the replication here. And this produces a whole bunch of different sequence lengths, which we then can put in order using the gel electrophoresis through a capillary, and then we can analyze the fluorescence with a laser. So that way the shortest ones, meaning so the very shortest ones will go first, followed by the next one, followed by the next one, giving you this output chromatogram telling you the fluorescence at each particular point. And this is what the machine looks like over here. So, and you can tell that there's a mutation when you come across and you find out in the chromatogram that you have these two fluorescent markers, right? So you've got the sequence equal to each other, and then all of a sudden you've got this mutation here, meaning that one of those is not quite right, with the red being the thymine and the C being the cysteine, indicating that there's a mutation right here. All right. So with that bit of revision, we're going to test our revised knowledge. How do we play Jeopardy, you might ask? So what's going to happen first is I'm going to reveal the question to you. Then whoever buzzes in first will have 10 seconds to answer. Feel free to, you can answer with your microphone, or you can answer just in the chat here, whatever you've got going for yourself. It's going to be a competitive advantage if you do answer with your microphone, so have that ready if you've got that going. If that person gets it correct, their team will get the points, the money that's associated with that question added to their score. If it's incorrect, we'll go to the next person and give them a chance to answer as well. The thing is, the thing about Jeopardy is it's all about how you answer the question. So you'll be given a prompt, and the prompt would be the sum of 2 plus 2. And so the answer to that is 4, right? Because 2 plus 2 is 4, but you've got to give it in terms of a question. So that's where it gets, you have to think about it a little bit. So the answer the answer is 4, but you've got to give it as if it's a question. So what is 4? Would be the answer to this one. So if you get the question right, you're still going to get points, but if you don't get it in the right format, you're only going to get half. Okay. So how do we select which question to start off with? Well, we get to pick from the board here. So there's a whole bunch of different categories, and each question is worth different amounts of money. So the $100 questions are the easiest, but they're also worth the least amount of money. And then going down, it gets more and more tricky until you get to the 500 ones. And we also have different categories associated for different areas of biology. The first one being Sanger sequencing, the stuff we just covered. We got PCR, the central dogma, so that's like DNA, RNA, protein, transcription, translation, regulation. You might remember that from last week. We got lab, tools, and techniques, and we also have eBay. So eBay is I went onto eBay and then I found a whole bunch of different things that were for sale in eBay, and that category is going to work a little bit different. So I'll explain it. I'll explain that one when we get to it. All right. So we're going to start off with the first person. We're going to start off with the green team, and I'd like for Max Rubio, please let me know where would you like to go? What question would you like to do first? Because you came in and you joined in first, so I'm going to give you the chance to pick the question first. So let me know, Max. What are we thinking? So if you're wanting to join a team, Haley, you go to buzzin.live down here, and then you join the game with this number. Transcription regulation, no worries. Do you want to just start off with 100, Max? Or do you want to go 200, 300, 400, 500? Or do you want to start off nice and easy and just doing 100? 300, all right. So starting off with a middle of the road transcription and regulation, 300. Transcription regulation 300. All right. So I will read out the question, and then once I finish reading the question, I will open the buzzers to take answers, and the first person to buzz in will get the chance. We'll get 10 seconds to answer. In eukaryotes, mRNA translation can be regulated by proteins binding to this region of transcription. Kobe coming in so quickly that, oh wow, well done, Kobe. All right, Kobe, you've got 10 seconds starting now.
I'm blanking, Hayden. Hold on.
5, 4.
This is not 10 seconds.
3, 2.
I forgot.
I'm sorry to see that, Kobe. Next up, we got EJ. Ready? You ready, EJ? So your time starts in 3, 2, 1.
What is the Tata box?
What is the Tata box? Let me check that answer. Ooh, sorry again, EJ. That's not quite right. We got Alfred, Daisy. Ready? You're up next. You'll give me your answer in 3, 2, 1.
What is the 5' UTR?
Excellent. I'll take that. The answer is, what is the 5' and 3' UTR? So well done, Daisy. I'll give it to you for what is the 5' UTR. Well done. So, blue team off to the races, 300. So, Daisy, because you got that last one, you get to pick the next question of where we go. Where would you like to go next?
I'll take eBay for $300.
eBay for $300. Okay. So, there is no time limit on this one, although everybody gets a chance to put it in. When it comes to eBay, you're trying to guess the price of things. So, right here, we have a plush doll of Jesus Christ. So, Daisy, you'll be representing blue team, and I need somebody to represent yellow team, green team, and red team to give me an approximate price of what you think this was going for on eBay. So, Kobe, I'll have you for yellow team. What are we thinking, Kobe? Or
$15.49.
$15.49 for Kobe. All right, Daisy, do you have something for blue team? And Ella, you can do green.
I'll go $29.99.
So Daisy, that was Daisy, sorry, wasn't it? For
yes.
$29.99. 99. And all right, Ella, you can absolutely do green.
I'd say 29.
29 flat.
Yep.
And I need, so that was yellow, green. I think I need a red. I need Max. Are you there for Team Red? If you're there for Team Red, Max, let me know. I'm green. Would somebody from the red team please give me, Emilia, your work, please give me an approximation of what you think this is worth. 24.99. So for the red team, we've got 24.99. For the green team, we've got 29 flat. For blue team, we've got 29.99. And for Kobe, for the team yellow, we've got 14.95. The answer was 24.99. So that brings us to Ella for the green team. Well done, Ella. Excellent. So we go back to the board, and Ella, for guessing that one correct, you get to pick where we're going next. Where are we going, Ella?
I'd say lab tools and techniques for $300.
Lab tools, techniques for 300. All right. Clearing buzzers. Lab tools and technique, 300. All right. Buzzers are cleared. Things are locked. That's ready to go. All right. This instrument is used to measure the absorbance of DNA and RNA at 260. Wow, Daisy coming in. You are on a hot streak today, Daisy. Well done. You've got 10 seconds starting now.
What is a spectrophotometer?
Well done, Daisy. I'll take that. What is a spectrophotometer versus nanodrop? Well done, Daisy. That was lab tools and techniques, 300 for the blue team, pulling ahead early out here. So, Daisy, where are we going? Back to the board. Where are we going?
I'll go PCR for 200.
PCR for 200. All right. Reset. Toggle that. Clear buzzers. All right. So, PCR 200. PCR requires 2 short DNA sequences that define a region to be amplified. Well done, Laura M. For the yellow team. Laura, you've got 10 seconds starting now.
Is it the primers?
Lovely. Well done, Laura. What are primers? Good work. Yellow team off the ground. We're going back to the board. Laura, tell me, where are we going next?
Could we do Sanger sequencing 100?
Sanger sequencing 100. We certainly can. All right. Sanger sequencing 100. Your question is, this molecule is used as a template for the Sanger sequencing reaction. We've got Haley M. For the team yellow again. Well done. Haley, your time starts now. Three, 2, 1. Unfortunate. We're going to the next person, which is Daisy. Daisy, you've got 10 seconds now.
What is a PCR amplicon or a DNA plasmid?
PCR amplicon. I'll accept DNA plasmid. It is what is DNA. Well done, Daisy. Excellent. So blue team coming into an early lead. Good work. All right, Daisy, where are we going?
eBay for 200, please.
eBay for 200. All right. Okay. We're going to eBay. So, this is your item. Dog food, specifically for a Shih Tzu. Daisy, for the blue team, can I have your guess, please?
$35.
$35 for the blue team. Volunteer for yellow, please. Haley, can I have a
what's the package size for it?
I don't know. That's all we've got.
That impacts the price.
That's all we've got right here, but keep in mind it's got free delivery. $50. Okay. I need a green team and a red team. Green team for Max, we've got 89.99. Oh boy. Coming in high for the green team. And finally, I need somebody from the red team, please. We got Amelia going $60 for the red team. All right. The answer is $50.96. Great job, yellow team. Almost nailing that. Giving a clawback, giving some competition here. Red team, we got to be picking this up. Come on now, red team. Somebody shows, we need to see some leadership going on out here. Come on. All right, Amelia. Sorry, Amelia, wasn't it? Was it Emily? Amelia? Can I please have some direction of where we're going next? Yes, Amelia. Perfect. Where would you like to go? Yes, you. Lab tools 100. Beautiful. All right. All right, here we are, team. Lab tools 100. Your question is, this tool allows precise transfer of small liquids, small volumes into the lab. Kobe coming in at the top there. What are we doing, Kobe? Your time starts now.
What is a pipette?
Perfect. Great work, Kobe. What is a micropipette? That goes well for me. All right, Kobe, where are we going from here?
Hold on, show the options, please.
Absolutely.
eBay for 500.
eBay for 500. Oh, man. Your item is a Berserk Deluxe Collection Set, mint condition, English sealed and not even touched. What are we thinking? Somebody from the yellow team, maybe you, Kobe. What do we think? Kobe 135, no worries.
Can you ignore Kobe?
Well, yes, if somebody else would like to put in an option for blue team, we've got
I'm gonna say 800.
800, and we got 1,000 for the blue team. 800 for yellow, 1,000 blue. Anybody for the red team? Green for 700, and I need somebody from red. Red for 800. All right. We'll split the points. We'll split the points if both red and yellow team have 800. However, the result is 982.28, giving it firmly to the blue team, taking big points there, pushing themselves ahead in the further. We've got to be set. Here we go. That's all right, Kobe. I appreciate the fact that you're even willing to give an answer there. So, well done there, blue team. I believe Daisy gave that answer. Can somebody please, from the blue team, let me know where we're going? Central Dogma, 200. All right. Central Dogma, 200. All right, that's reset, that's reset. Your question is, this process produces an RNA copy of a DNA sequence. Laura for the blue team coming in. You have 10 seconds starting now.
What is transcription?
What is transcription? Great work. Well done. So that is 200 for Laura, who is part of the blue. You were part of the blue team, I'm pretty sure, weren't you? Yeah.
Correct.
Excellent. Where are we going, Laura? Take us. Where are we going next?
PCR for 400.
PCR 400. All right. Did I skip over? Here we go. So that's reset. That's reset. That's reset. Your question is, This parameter of PCR determines the specificity of primer binding during the annealing step. Max for the green team. Where are we going? Your time starts now. Max, are you there? What is PCR amplicon size? No. I apologize. I revealed that one a bit too early. I panicked. That's on me. We will discount that one and we'll come back to this one a bit later because that one's on me. I accidentally revealed the answer. So we'll come back to this one a bit later. I'll think of something else. Sorry about that. That's on me. However, I'll pick the next one we'll go to. We're going to go PCR 300. All right. Ready, PCR 300. Your question is, this step of the PCR involves heating the DNA to around 95 degrees to separate the strands. Liam for the green team, you coming in first. Ready, Liam? Your time starts now. What is denaturing? Liam, quick on the draw. Excellent work, Liam. Great work for green team. You got 300. We're coming back here. We've got a fighting chance yet. All right. So, Liam, let me know. Where are we going? eBay for 100. All right. A bag of Smith's cheese and onion. Keep in mind, there is free shipping. So, Liam, what are we thinking? Oh, I need a yellow, I need red, I need green. What is the price of this on eBay? Daisy for the blue team, we've got 250. Red team, we got $3 from Thomas. I need yellow and green. See Kobe there going for 470. You can answer for green if you want, but I need an answer for green team. All right. Haley, are you part of the green team? I'll do 7 for green from Liam. All right, here we go. The answer is 325, which brings the red team to the closest. Red team, we are on the board. We're here. We are here. Let's go, red team. Big ups for red team. We're on the board. All right, let's go. Okay, so Max. I need to know where we're going. What's the next? Central Dogma, 400. All right. Here we go. That's toggled. That's reset. That's cleared. Here we go. Your question is, in eukaryotes, this modification is added to the 5' end of the mRNA to protect it and aid in translation. Your time, I want to hold up 1 second. Okay, your time starts now. Well done, Rith. I saw that you came in there early. Well done. Rith, you have 10 seconds starting now.
What is ssDNA?
What is ssDNA? Unfortunately, that is not quite what I've got here. We're moving on to the next person. We've got Michaela for the blue team. Your time starts now.
Would I be stumped and have forgotten?
Oh, that's all right, Michaela. Better luck next time. We're going to Daisy. Your time starts now.
What is the Tartar box?
Unfortunately, not quite. I haven't got that one quite yet either. Oh no, it might not be as hard as people are thinking it is. We're going to go to one more person. We're going to go to Laura from the yellow team. What have we got, Laura?
Oh shit. Is it the methyl cap?
The methyl cap? Unfortunately, it's not as hard as this one. Is probably a little bit of a tricky one because I've just got the 5 cap. Unfortunately. So we're going to pass on that one. The poly A tail is a great guess, but that one is at the 3' end. I just had to double check that I didn't accidentally put the 5' rather than the 3'. So that one is a wash. Unfortunately, nobody gets the points for that one. But what we do is we just move on to the next one in the central dogma, which is going to be the central dogma for 100. Over that, clear that. Central dogma for 100. All right, ready? Okay. So that's reset, that's cleared. Okay, team. Your question is, the central dogma describes the flow of genetic information from DNA to mRNA to this molecule. Rob, we've got Rob from the blue team. You've come up first. Rob, your time starts now. What is protein? Well done, Rob. What is protein? Great work. Rob, you're part of the blue team. So, blue team with another 100. Where are we going, Rob? $200 Sanger. Love it. Toggle that, reset that, clear buzzers. Okay.
That's the 300 question.
Thank you. Thank you. Sanger, 200. Ready, your question is, this enzyme synthesizes the new DNA strand during the Sanger sequence. EJ, for the green team, your time starts now. 5 seconds, EJ. 2, 1. Oh no, that's unfortunate. We've got Laura from the blue team. Your time starts now.
What is DNA polymerase?
That's good enough for me. Exactly right. Well done. So that is for the blue team. Another 200 there. Taking it away here, blue team. We got to be working together to catch up here, team. Come on. Come on, green team. Come on, red. Come on, yellow. Let's go. All right. What are we doing? Laura, where are we going?
Lab tools and techniques for 400, please.
Lab tools, techniques, 400. That's eBay, lab tools, techniques, 400. Toggle that, reset that, clear that. All right. Your question is, this stain intercalates into DNA and fluoresces under UV light, making DNA visible in gels. We've got G from the green team. You've got
electrolysis?
Gel electrolysis, not quite. We're going to go to the next person, which is Haley from the red team. Oh, not sorry, Haley from the yellow team.
Yeah, is it CyberSafe Red?
CyberSafe Red, not quite. Sorry, Haley. We're going to move on to somebody from the red team. Here we go. Come on, Red Robot. Here we go. Come on, Red Robot. You've got 10 seconds starting now. Oh, that's all right. So we've had somebody from the green team. We've had somebody from the blue team. Actually, we haven't had somebody from the blue team yet. So the next person who's from the blue team is Rith. All right, last chance, Rith. What do we got? What is the name of this particular stain? What's it called? You've got 10 seconds starting now. Come on, Rith. What do we got?
Crystal violet?
Crystal violet.
What is crystal violet?
Might need a clarification here. My answer I had was ethidium bromide or DNA stain, but let me just check. I'm gonna make a check here. Hold. Hold. Yes, it is used. I'll give that to you, Rith, because Crystal Violet is used as an alternative. So I'm happy to award you the points there. Well done, Rith. Well done. So Rith, you are part of the blue team. Oh my goodness, blue team, pulling it away. Where are we going, Rith? Where are we going from here?
Transcription translation regulation 200.
200 for the middle one here. All right, so transcription, transregulation, 200. Toggle that, clear buzzers. All right, your question is, these regulatory DNA sequences can be far from the promoter, but still increase transcription when bound by its activator. EJ, right up the top there. Your time starts.
Enhancer regions.
Enhancer regions. What are enhancers? I'll give that to you.
What are enhancers? Sorry, I forgot the format.
That's all right. I will have to give you half points for that, EJ, but you still got the right answer. So great work there for the green team. Well done. And I think there's been a bit of a mutiny in the... Well, there's methyl caps are acceptable. Fair enough. How is it? I think 5 aspect is 5 prime aspect. Well, fair enough. Laura McDowell, you were the one that gave the said methyl caps then, didn't you? Excellent. And what team were you a part of? Yellow. Excellent. Do you remember which question was that from again? $1,000 question. That's right. We'll go a quick back. Here it is, 400. So we'll give 400 to the yellow team. There we go. Beautiful. So, EJ, you just got this one here for 200 transcriptions. So, where are we going from here?
Okay, I'm saying the PCR for 500.
PCR for 500. All right, EJ, here we go. Gonna toggle that, reset that, clear that. PCR for 500. All right, your question is, this method of PCR uses reverse transcriptase to first convert RNA to DNA before amplification. We've got Rob from the blue team. Your time starts now. What is RT-PCR? All right. So what? PCR 500. What is RT-PCR? That works for me. Well done, Rob. What is reverse transcriptase PCR? Love it. So for the blue team, that was Rob for the blue team. Another. Woo, boy. All right. Where are we going, Rob? Where are we going from here? Central Dogma 500. Oh man. So toggle that, reset that, clear that. Beautiful. Central Dogma for 500. Your question is, in eukaryotes, genes are often split into coding regions and non-coding regions. The non-coding regions are removed during RNA creation process. All right, we got Max from the green team. What are we doing, Max? You've got 10 seconds starting now. What is an intron? Max, you've hit it on the head. Well done, Max. Well done. Let's go. So that's, you love to see it. Red team, we're back in it, baby. Don't worry. We're never gone. We're never fear. It's never too late. All right, Red. Max, what are we doing? Oh, you're green? My mistake. I'm sorry, Red team. I'm sorry. That was on me. But yes, we're still in this team. It's not up. Okay, so Max, where are we going? What's next? Trans-Tri-Reg 400. All right. Toggled, reset, cleared. All right, transcription. That's 100. We're getting down to it. Your question is, in humans, multiple proteins can be made from a single gene through this process of transcription modification. We've got EJ killing it for the green team, coming in way ahead of the competition.
What is
EJ,
splicing?
what is splicing? I'll give that to you. The full answer is what is alternative splicing, but that's close enough for me. Well done. So I'll give that to you for 1,700. All right, EJ, where are we going?
Let me just look. I say lab tools and techniques for 500.
Lab tools and techniques for 500. We're coming close to the end here, team. Keep going strong. Lab tools and techniques for 500. All right. Toggle reset clear. Toggle reset clear. Your question is, this technique uses specialized proteins that cut DNA at specific short recognition sequences, producing fragments useful in cloning and other analysis. All right, we've got Laura from the blue team. Your time starts now.
What are restriction enzymes?
What are restriction enzymes? That's correct. What is a restriction enzyme digest? I get what you're coming from. I'm not here to be mean. Well done to you. Excellent. All right. So, Laura, where are we going? We're coming down to the wire.
Lab tools and techniques for 200, please.
Lab tools and techniques, finishing it out. Lab tools and techniques. All right, your question is, the technique separates DNA fragments by size using an electric field. Now we've got Kobe for the yellow team. What are we doing, Kobe? Your time starts now.
E-gel.
E-gel. I'll give it to you, but I needed the answer in terms of a question. But I'll still give you half points, so that gives you up to a full 1,000. Well done, Kobe. Where are we going next?
Transcription and translation 500.
Transcription, translation 500. It's 100. Here we go. 500. Transcription, regulation 500. Your question is, this enzyme digests the mature mRNA strand through the poly-A tail. We got one from Daisy. Your time starts now. What are we doing, Daisy? What are we doing?
Wait, I didn't even hit unmute.
That's all right. 2 seconds. What do you got?
Polyadenase, I have no idea.
Polyadenase. That's unfortunately not quite right. We're going to go to Haley starting now.
RNA polymerase?
Unfortunately not quite right, Haley. We're going to go to Max for the green team. No, sorry, not. All right, so now we got free reign for the red team. Red team, anybody can come in and give me an answer. I need somebody from the red team. Free reign. We've had one from the blue, yellow, and green. Is there anybody from the red team who wants to give an answer? I'll give it 10 more seconds to buzz in. All right. What is poly-A polymerase? Not quite right, sorry. It would have been, I would have accepted nuclease or deadenylate. I would have accepted that one too, Daisy, unfortunately, but somebody from your team already answered. So unfortunately, that one is a bit of a wash as well, but that's okay. We'll go back to the board and we'll go right back into it. So I think we're going to take it to, we haven't done a Sanger sequencing one, so I'm going to take us to Sanger sequencing for 300. Reset this. Sanger sequencing for 300. Your question is, This type of nucleotide lacks the 3-hydroxyl group, causing a chain termination when incorporated. We've got Laura from the blue team. Let me know, Laura, what do we got?
What are DDNTPs?
Perfect. That's good enough for me. What is a DDNTP? Well done, Laura. 300 again for the blue team. All right. So, toggle that, clear that. Laura, where are we going?
Central Dogma 300.
Central Dogma 300. That's ready to go. That's ready to go. Excellent. All right. Your question is, this organelle is the site of translation. All right, EJ. We've got EJ for the green team. You've got time starts now.
Ribosome. What is the ribosome?
There we go. I'll take that. You got there before I revealed the answer, so I'll give it to you for that one. Well done, EJ. What is the ribosome? Okay. EJ, where are we going?
Just bring it back up. Let's say PCR for 100.
PCR for 100. Nice and easy. That's reset. That's ready to go. Beautiful. All right. This enzyme is used to synthesize new DNA strands during PCR. We've got Laura from the blue team. What are we doing, Laura? Your time starts now.
What is Taq DNA polymerase?
Love it. Good work, Laura. That is 100 points for the blue team. Excellent. Okay. So, where are we going? We're only down to a few. We've only got 4 questions left. What are we doing?
eBay 400.
eBay 400. Here we go. Here it is. So, your item is a robot vacuum cleaner. Can I please have an answer from each of my teams? So for the blue team, we've got 375. Green, red, yellow, please. Yellow, 400. Anybody from the green team? Red is 120. And the green, the first one I see is from Liam being 250. All right, so red team, $120. Yellow team, 400. Blue, 375. And green team for 250. Our answer is $400 for the yellow team on the money. Here we go. Yellow team pulling it back. Nice one, yellow team. Kobe coming in clutch there. Tell me, Kobe, where are we going?
Great question, Hayden. Let's go. Let's do the transcription and translation, please.
Transcription, translation for 100. So here we go. Reset, reset, reset. Your question is, this type of protein binds DNA sequences to increase and decrease transcription. EJ coming in super quick on that one, EJ. All right, you've got 10.
What is a regulatory sequence?
What is a regulatory sequence? What is a regulatory sequence? Not quite, EJ. You're close, but not quite.
What is a regulatory protein?
I'm sorry, EJ. I'm going to have to move on to the next person, but you're very close there. We're going to Daisy, who's there. Next, Daisy.
What is a transcription factor?
What is a transcription factor? What is a transcription factor? Well done, Daisy. So close there, EJ. So close. But Daisy, where are we going? I think we've only got a couple options left. What are we doing?
We'll go Sanger sequencing for 500.
Sanger sequencing for 500. All right, toggle that, reset that, clear that, and we're ready to go. Your question is, the maximum read lengths in base pairs typically achievable by Sanger sequencing falls within this range. We've got Daisy coming up again at the front there. Daisy, your time starts now.
What is 900 base pairs?
What is 900 base pairs? I'll give that to you because it was anywhere between 500 and 1,000. So I'll take that for you, Daisy. Well done. All right, so coming in to the penultimate question. Sanger sequencing for 400. Reset that, toggle that, clear that. Beautiful. All right, so here we go. Last question, penultimately. In modern Sanger sequencing, each DD-NTP is tagged with this kind of molecule to allow for the detection of the terminating base. We've got EJ for the green team. Here we go, EJ. What are we doing? 10 seconds now.
Sorry, I just realized I was on mute. Isn't it a fluorescent tag? What is a fluorescent tag?
What is a fluorescent tag or a fluorescent dye? That works well. And you said it as a question the first time anyway, so I'll give it to you. Great work there, team. Well done. So the main part of Jeopardy is done, but we're not over yet. We've still got Final Jeopardy. So it is not all over yet. Any team can still win here. But what we've got to do is one of your team representatives will determine how much money they're going to bet for their points. That team representative will have 10 seconds to answer the Final Jeopardy question. Whoever guesses it correctly first will take their money and times it by 2. So, I just have one question. Who's the representatives? I need a representative for the red team. Will anybody step forward from the red team? Anyway, I need a representative for the yellow team, please. Kobe, would you be a representative for the yellow team? Excellent. Blue team. All right. So, Daisy volunteering first. I saw Daisy volunteer first. And for the green team, do I have a volunteer for the green team? EJ, you happy to be the representative, EJ?
I'm so scared, but okay.
Yes, excellent. So, I'm going to need bets from the yellow, blue, and green team. How much? Actually, I'm hiding the chat here. If you can, send it directly to me, please. How much you want to bet. Okay, yellow team is locked in. Blue team is locked in. Just waiting on EJ. Take your time, EJ. All right. Green team is locked in. Okay. So. I'm just hiding the messages so they don't spoil the fun. But we're back here, team. We're back. Okay. So, for Kobe, Daisy, EJ, we have your Final Jeopardy question. We want the first person who gets it right will be considered the winner. I'm doing away with the 10 seconds. So you can take as much time as you like. However, the person who is send me the answer directly in the send it to me directly in chat, and whoever sends it to me gets it right first will win. Your question is, while Sanger sequencing typically produce read lengths of 800 to 1,000 base pairs, this newer sequencing approach surpassed it through massively parallel short read sequencing. So, Kobe, Daisy, EJ, as quickly as you can, send me your answers. Green team is locked in. Green team has locked in their answer. Still waiting on blue and yellow team. Blue team has locked in their answer, just waiting on yellow. Kobe, is that your answer? Okay. We have it there, folks. We have it there. So, for the green team, we had what is cycle sequencing? For the yellow team, we had what is Hayden? And for the blue team, we had what is next generation sequencing? The answer and your winner for the first ever final Jeopardy of LQB280 is what is next gen sequencing? Well done, blue team. Congratulations. We have the victors. Well done. And with a final score, they bet 1,500, giving you a total score overall of 7,200. Yellow team unfortunately bet everything, fair enough, but leads them with nothing. Green team bet 2,000, leaving them with 400. Blue team taking the sweep away. Thank you everybody for playing. Thank you for contributing. I want to thank Kobe and EJ for putting in big efforts here. Laura, Haley, Michaela, Ruth, you all did some great work today, and good on you for contributing to your team. Well done. You made it such a great game. And well done for those who did contribute to the red team. You have to be in it to win it, and you never make fun of the man in the arena. Well done, everybody. Okay, so that brings it to a conclusion for this week. However, I am still around for one more tutorial week. So next week, what we will be doing is being on mid-semester break. So I hope you all enjoy that. But the week after that, we will be doing Dungeons and Dragons. Yes, indeed.
Sounds exciting.
Indeed. So, if you would like to give me some feedback, please feel free to email me, foxh3, good, bad, indifferent. If you would like to keep it anonymous, you're welcome to do it through the anonymous student survey at the end of the week. But yes, thank you all for joining me, and that's all I got for this week. That's all I got.